Find the period of these three functions. We have y equals sine of 3x, y equals sine of 2/3 of x, and y equals sine of pi x. Okay, so what we want to do is we sort of just want to compare this to just sine of x. Okay, once again, we have the number being multiplied to the x term here, right? That refers to the period of the sine function, right? The number is not in front here or being added or subtracted anything out here, right? So this number refers to the period, right? So generally we can write it as y equals sine of bx, right? And what this b does, it determines the period of this function. Now you got to be a little bit careful, right? The period is 2 pi divided by b, and you want to remember this, okay? We usually denote that by the capital letter T, okay? So the period is 2 pi divided by whatever this coefficient of x is, okay? So b does not represent the period, right? It's 2 pi divided by b, okay? Now what is the normal period for the sine of x? Okay, the normal period is 2 pi, okay? So here's the graph of sine of x, okay? So what does it mean, the period? The period is one complete wave, okay? So that will be from here, right? We go up, we go down, and then we come back to the original location where we start. Okay, this point here would be 2 pi, and that is the length, right, of one complete wave. So then what happens to this guy, right, the sine of 3x? Well, so what we want to do then is just take the b value, right? Here b is equal to 3, so then the period would be 2 pi divided by this number, in this case, divided by 3. That's the period. So how does it change the shape of the graph? Okay, so here's a little trick that we can do. Okay, instead of plotting, pi over 2, pi, 3 pi over 2, and 2 pi, okay, and then trying to fit the graph into that, right? Let's just plot one complete wave. So we'll just draw one complete wave here, which is from here to here. But then what does that mean? What is this point here, right? The period is 2 pi over 3. That means this point is 2 pi over 3. Okay. So that's one little thing we can do to make the graphing a little bit easier, okay? Now, we do, or we should, find these points, right? We always want to find the max, the min, and any x-intercepts here. Now, you got to remember, this graph is separated into 4 equal parts, right? Okay. So we know that the length from here to here is 2 pi over 3. So this point here should be exactly half of that, right? So 2 pi over 3 divided by 2 is pi over 3. This point here should be pi over 3. Okay. Similarly, this point should be the middle point of these two. So this will be pi over 6. Okay. And this point is the middle of these 2 points. So we need to add these two guys together. Okay. We need to add these two guys together, okay, and then divide that by 2. Right? We're taking the average. Right? So this point is the average of this and this. So pi over 3 plus 2 pi over 3 is just pi. Divide that by 2. We'll get pi over 2. Okay, so this point here is pi over 2. Okay. So that's how we find these points, right? We're just taking the average of the endpoints. So what about this guy, y equals sine of 2/3 x? So we'll do y equals sine of 2/3 x. So what is the b value here, right? B is equal to 2/3. So that means the period then, right? The period is going to equal 2 pi divided by 2/3. Remember, we never divide by fractions. We always multiply by the reciprocal, right? So this becomes 3 pi. Okay, so 2 pi times 3 over 2, which equals 3 pi. So we can do the same thing here. Okay, instead of making your xy graph here and plotting, pi over 2, pi, 3 pi over 2, 2 pi, like we normally would, right? Let's just draw one complete wave. Okay. We'll draw one complete sine graph here. Okay. We don't need to go both directions, but here's where we begin. We go up, we come back down, and we end up right back where we started, right? So this is the length of one complete wave. But what does this length represent? That's 3 pi. All right, so this point here should be 3 pi. Okay. So now we should be able to find this point, and this point here, right? So this is the middle point, right? This is the middle of 0 and 3 pi. So 0 plus 3 pi is, of course, 3 pi. Divide that by 2, we get 3 pi over 2. Okay. This point is also the middle of this point and this point. So we want to add these two guys together, divided by 2. 0 plus 3 pi over 2 is just 3 pi over 2. And then times that by a half, we get 3 pi over 4. That, well, once again, that we can do that just because of the 0 here, right? That makes it a little bit easier. But what about this point, right? We have to add these two guys together and then divide that by 2. Okay, we're taking the average. Okay, so 3 pi over 2, we'll write that one out, I guess, plus 3 pi. Okay, and that, remember, we always, whenever we add fractions, we always need the LCD. So this becomes 3 pi over 2 plus 6 pi over 2. That gives us 9 pi over 2. But we have to divide that by a half, right? Remember, we're taking the average. Okay, dividing by a half is the same as dividing by 2 is the same as multiplying by a half. So this point here should be 9 pi over 4. So we got the x-intercepts, we got the maximum value and the minimum value here. Okay. Lastly, what about y equals the sine of pi x? Okay, this one looks a little bit tricky, but what is the b value here? The b value is pi. So the period is going to be 2 pi divided by pi, which actually just equals 2. Right? And that one looks a little bit weird, but if we draw one complete wave here, running out of space, but what is the distance from here to here? We've determined the period, right? The period is 2. So this point would just be the point 2, right? There's no pi there. That looks a little bit weird. Yeah, but that happens sometimes, especially if you get numbers that look like this. Okay? So this one should be a little bit easier, right? This is the point 2, which means this should be half of that, which is 1. So this is 1/2. And then this point here should just be 3/2. Okay? So these are the graphs for these particular functions.